Okay, so now just looking at examples for prerequisite section 6 on factoring. We're going to try to factor this. I know it looks crazy, but we're just going to have to go through it step by step and try to factor this all out ourselves. What I happen to notice is let's take out the same number in all of them, and they all have divisible by 8. So let's take an 8 out of all of them. 16 divided by 8. We also have 64 divided by 8 and 24 divided by 8. So I can take that out. Looking at the x's first, and I notice that there are 5 x's in the middle term. And there are at least 5 x's in the last term, leaving me with 1 x left over in the last term. And there's at least 5 x's in the first term, which will leave me with 2 x's in that one. So what that means is I'm taking 5 x's out. The y's now. Does every single term have a y in it? No. So I can't take y's out of everything because every single term does not have a y. Z's. Does every single term have a z? Yes, it does. That has 2 of them. This has 4 of them, leaving me with 2 left over, and this has 4 of them, leaving me with 2 left over. So I can take a z squared out. So with all that I'm taking out, 16 divided by 8, I have a 2 left over. I still have 2 x's left over. Still have that y, didn't even touch it. And now I have 2 z's left over. I took out an 8, so 64 divided by 8, since it's minus, that's why it's a minus 8. I took out all of my x's because they're x to the 5th. Y cubed didn't even touch. I took out 2 z's, so that means I have 2 z's left over to give me that 4. Divided by an 8, because I took an 8 out, so 24 divided by 8 is 3. I took 5 x's out, leaving me with 1, and I took all my z's out, leaving me with no more z's, and there is that factored. We can slide and divide with this one to try to factor it, right? So slide and divide, slide that 3 over, 3 times 2 is 6. So I have x squared minus 5x plus 6. So can you think of 2 terms that multiply together to give you 6, that also add together to give you a negative 5? Well, when we do that, right, negative 2 times negative 3, that's positive 6. Negative 2 plus negative 3, that's negative 5, so it works. So I can separate this into a negative 2 and a negative 3. However, I slide by 3. So if I slide by 3, that means I need to divide each of those by 3. So this simplifies, because it can divide them both by 3, to a negative 1. So I get x minus 2/3 and x minus 1. But you can't write factors as fractions. So I'm going to take that 3 and slide it over. So I actually get a 3x minus 2 and an x minus 1. So with this one, we got to remember some of the factoring formulas to solve this one. Since it's squared, can you see anything else that happens to be something squared? As in, can you rewrite 49 as something squared? Yep. I can rewrite that as 7 squared. Can I rewrite 9 as something squared? Yep. I can rewrite that as 3 squared. So I actually have the difference of squares. My first term is just a number. So the first term is a 7. The last term, when I put them together, is a 3y. So the point being, it's the first term minus the second term, and the first term plus the second term. And there are my 2 factors. With this one, we do not have the difference of squares. We do not have a difference of cubes because we have a 4 and a 6. However, can I rewrite them as either or? So look at the numbers. Can you think of a number cube that will give you 16? No. You think of a number cube that will give you 9. Most of you are probably saying, yeah, but no, you cannot. Okay? You're thinking, yes, there is, but for something squared. You can rewrite this as something squared, and you can rewrite 9 as something squared. So the point is, 16 can be 4 squared. I can rewrite y the 4th as y squared squared because 2 times 2 is 4. I can rewrite 9 as 3 squared and z as cube squared. 3 times 2 is 6. So I need to put my terms together. A 4 and a y squared becomes one term, and a 3 and a z cubed become one term. So according to difference of squares, it is the first term minus the second term, and the first term plus the second term, and there are your two factors. So now taking a look at this problem, we have to see what we can come up with. And why don't we finish off these examples when we come back?